my name is CHUN, and today I will be introducing about linear regression. So, what is linear regression? It may sound like a very advanced and complicated concept, but it's actually surprisingly simple. Linear
Sorry.
regression is just...
스탑. 다시 들어오고.
네.
왜냐면 이제 지금 공통된 실수들 너무 계속해서 선생님이 얘기하는 거야. 자, 준영아 얘기를 할 때는 너가 그 KGSEA 매스서클 멤버인 걸 알려주고 그 다음에 현재 너의 소속에 대해서 알려줘야 되고 너의 학년에 대해서 알려주는 게 맞는 거지.
네네네.
다시 처음부터 한번 해봐.
네. Hello, my name is CHUN from the KGSEA Math Circle, and today I will be introducing linear regression. So, to start off, what is linear regression? It may sound like a very advanced and complicated concept, but it's actually surprisingly simple. Linear regression is just expressing a group of scattered data points into a line, like this. The blue dots in this graph are expressed by this red line, and through this line, we can predict a different data point by following the line. So, how is linear regression done? We first need a set of data like this. The larger the set is, the better, because the line can become more correct. This set of data in the PowerPoint consists of age, sex, and where the 1 is female and the 2 is male, and whether they smoke or not, where 1 means that they do smoke and 2 means that they do not smoke, and their height and weight. But because we are doing linear regression with only 2 variables, we need a data set with just 2 factors. So from this big data set, we will consider the height and the weight factors of this data set and find a relationship between the 2 factors. So now we will change each data point into coordinates by turning each factor into x and y values. So the height and weight of each person will become the x and y values in a graph. Now, like this graph, each data point of height and weight can be drawn as coordinates. Each red dot represents a person, and their position in the graph is their height and their weight. Now we will have to draw a line that can express this group of points effectively. So first, we will draw a line through the data that seems to pass the middle. Next, with this line, we will find the distance from each point to the line drawn. Now this distance is called a residual. So each residual of each point is squared, and the sum of all the squared residuals is called the error function. This function is a function that shows how much the line is supposed to express the given data is actually different from the actual data. So it is talking about the error, about how different the points are from the line. Now we divide the total error by the number of the data points drawn in the graph, and now we have something called the mean squared error. The mean squared error function is called the mean squared error function because the function is calculated by squaring each residual, which is the error, which is the difference between the actual data point and the predicted data point on the line drawn. So this function, it can look very complicated, but it's just merely showing what I expressed before into an equation. So as you see here, yi is called the observed values, which are the actual values of the data point, and yi hat is called the predicted values, which is referring to the corresponding point on the line that I drew. So the difference between yi and yi hat, which is yi minus yi hat, is the distance between the point to the line, which is called the error and the residual, like I told you before. Then this residual is squared and all added up into a sigma, and then divided by the number of data points, like I told you before. So then we will have the squared error, and then by dividing it by the number of data points, we will have the mean squared error. So this equation can find the mean squared error of the line drawn. So if we calculate it like this and rotate the line a little bit, and then find the mean squared error again, using the same process that I mentioned before, then the mean squared error from this different line will be different from the one that we calculated before, with the horizontal line. The reason for this is because the distance from each point to the line has changed. So the sum of the squared residuals will also be different. Again, we will rotate the line a little bit more and do the same steps like before, where we find the mean squared error and then calculate how much it is different. The mean squared error will again be different from the ones that we calculated before because the distance between the dots and the line is again different from what we drew before. So after many repetitions and many different rotations like this, we will then plot the different mean squared errors corresponding to each rotation. So we will draw what the mean squared error is for each rotation and the angle of the slope. And by plotting the mean squared errors, we can see how the mean squared error changes by rotating the slope. And then we can find how much the line should be rotated so that we can get the least mean squared error. And the least mean squared error, this line that corresponds with it, will be the one that most effectively represents the data set given or the cluster of red dots shown in the graph. And this line is called the line of best fit, or also known as the regression line. This way of finding the line of best fit is called the least squares method because we found the line that has the smallest value of mean squared residuals, hence least squares. The least squares method can also be used in other regression processes other than linear regression, such as regression with a curve in second order, or also logistic regression, which is using a special function like the sigmoid function or the ReLU function. And this is the whole process of linear regression. And now we can predict the value of other data points by using the line of best fit and following the line, and we can predict what data set will be closest to what we drew. So like this, for example, we can predict someone's weight by only knowing their height because the red dots were according to their height and their weight. But finally, why is regression important and why do we need to know it? Regression may seem useless by just looking at what it is, but because we draw a line and we predict data, it is pretty important because by predicting data through looking at other data sets and comparing the predicted data with the actual data and finding the error, artificial intelligence can do machine learning through this process. So by finding the error in their prediction through regression, artificial intelligence can alter and revise their algorithm and their learning programs to lessen the error. Of course, by only using linear regression and only doing the processes that I have explained, this is just merely one way of doing machine learning, and it will not have a great effect in changing the algorithms in artificial intelligence. However, by utilizing many different regression models and repeating the same regression models over and over again, machine learning will have a great effect and it will change a little at a time, but it will change greatly by doing many different repetitions. And then artificial intelligence can be even more smarter than before. So by learning and understanding this kind of regression, you can become one step closer to the changing world and new technology. Thank you for listening.